Okay, let's see. We on here? I am on. Okay, good. Thank you all for coming to the 11th annual William Marshall Bullitt Lecture in Astronomy. These lectures are named after a U of L alumni from the law school, William Marshall Bullitt, who was the Solicitor General of the United States, a prominent lawyer in Louisville and Kentucky, and also a collector of rare books in astronomy and mathematics. And he created perhaps one of the greatest collections of first edition books in physics, astronomy, and mathematics in the world. It includes books by Copernicus, Galileo, Newton, Einstein, and Legendre, Lagrange, etc., Gauss. Over 170 books, which are now, thanks to the generosity of his family, housed here at the University of Louisville in the rare book collection. In his honor, his family has funded 3 lecture series, one in astronomy, one in mathematics, and one in fine arts, and also in the memory of his wife, who was a very prominent American artist of the early 1900s. Tonight, we are honored to have Dr. Linda Spilker coming here to provide us with a talk on the Cassini mission and its exploration of the Saturn system. But before we get to that talk, I would first like to introduce William Marshall Bullitt's grandson, Mr. Lowry Watkins, who has, through his generosity, allowed us all to be here tonight. And what's more, has endowed 2 funds to help students in our department. All right, could you please? The first award is a scholarship for outstanding achievement in astronomy and outstanding promise in astronomy. And this year's award goes to Jenna Lichtenberger. Interesting. Jenna is a junior in the Department of Physics and Astronomy and is working on studying Lyman break galaxies with Dr. Lutz Haber-Zettel, who is back there. The second award is for the best publication in astronomy and astrophysics for this year. And this is the second time this award has been given. And this year it is going to Jeremy Hornbeck for his publication on PDS 144, the first confirmed Herbig AE wide binary system. So, thank you, Larry. Okay, Tim, do you want to handle the introduction?
Thanks, Jim. Thank you, everyone, for coming. I'm going to say only a brief few words because we have an incredible talk today. We're really honored that Dr. Linda Spilker from the Jet Propulsion Laboratory, NASA in Pasadena, California, has been able to come here this year to give the 11th Bullitt Lecture in Astronomy. And what is a more famous or beautiful planet than the planet Saturn? And I would argue that this Cassini orbiter mission is perhaps the most successful planetary orbiter mission we've ever had. And we're going to see a greatest hits, beautiful exposition of all of the latest discoveries, some of which you may never have seen before. And we're just honored and thrilled that Dr. Spilker could come and give this. She's the head scientist, so she's the top boss, big honcho of the mission, and delighted to have her come here. Dr. Spilker did her work at 3 different universities, Cal State Fullerton, Cal State Los Angeles, UCLA. She's an expert on rings. What better planet to be the chief scientist of a spacecraft than Saturn? So let me read the title. Cassini-Huygens explores the Saturn system, recent discoveries, and science highlights. Give it over to Linda.
Great. I'm going to use the mic on this. Yeah. Yeah, thank you very much, Tim. I'm very happy to be here in Louisville, and I'm very excited to share with you especially some of our more recent discoveries and highlights in the last year. And what you see up here is sort of some teasers. By the end of my talk, you'll have heard about every single image here in this first panel. So stay tuned to learn a lot about the Saturn system. Well, Cassini-Huygens was named after 2 famous astronomers. The first, Christian Huygens, he discovered Titan, as well as the true nature of Saturn's rings, that they were made of particles, that they weren't individual disks of material going around. And since he was the discoverer of Titan, the probe that went into Titan's atmosphere was named Huygens in his honor. And Giovanni Dominique Cassini was an Italian-French astronomer, and he discovered a gap in between 2 of Saturn's rings, named the Cassini division in his honor. So it's quite appropriate that the spacecraft is named Cassini. Here's a picture of the orbiter and the Huygens probe. You can see that the orbiter here is about the size of a 2-story building. Here's some people for scale. And here's the Huygens probe all buttoned up on the spacecraft and ready to go. This is a joint mission both by NASA and the European Space Agency. We have about 270 scientists, and about half of those are from other countries besides the United States. Here's the Huygens probe without its thermal blanket on it. You can see the heat shield material as it's going to parachute into the atmosphere of Titan. Here's the Cassini spacecraft, 22 feet tall. This high-gain antenna up here is 13 feet in diameter. The spacecraft itself is 2.8 metric tons, and when you put the probe on it and fully fuel it, it's about 6 tons. So that's a lot to lift on its journey to Saturn. About 700 watts powered the spacecraft at Saturn orbit insertion, and you can see here that's provided by 3 radioisotope thermoelectric generators. We take the heat from the decay of plutonium, turn that heat into electricity, and it powers the entire spacecraft. There are a series of remote sensing instruments on board Cassini, including a suite of optical instruments that look from the ultraviolet through the visible, near infrared into the far infrared, and they're on a platform. Let's see, the platform right here are all of the instruments. There's a narrow and wide angle camera. We can take spectra to determine the composition of the instruments, look at lines for atoms in the ultraviolet. We also have a couple more remote sensing. One of them is a radar, and that's particularly effective for Titan. Titan has a thick smog around it, and so we pierce through Titan's haze to map it, much in the same way that we mapped Venus. We also use the radio system as a science experiment. As Cassini goes behind the planet or the rings, we send a radio signal to Earth, and we look at how the signal is changed, and that tells us a lot about the atmospheres and about the rings themselves. Then we have a suite of 6 fields and particles instruments here, measuring protons, electrons, ions, neutrals, measuring the dust. There's a cosmic dust analyzer on board. Here's the cosmic dust analyzer, and here's the palette that contains those other instruments. This long boom here is a magnetometer boom, can measure the magnetic fields, especially around Saturn, and also have a series of these antennas here, that radio and plasma wave antennas to detect lightning. The heads of those teams, 10 of the heads are in the United States, and these blue stars indicate the locations of those teams. 2 of the heads of the teams are located, one in the UK for the magnetometer, and one in Germany for the cosmic dust analyzer. 17 flags indicate the countries that are involved. Cassini is truly an international mission, both in the hardware that was provided, as well as the scientists that now work on Cassini. Here's the launch, launched in 1997 from Kennedy Space Center. It was a pre-dawn launch, very beautiful. We took our daughters out of school for a week. They were very happy about that, to go down and watch Cassini launch. And I still have vivid memories of watching it go into that cloud. The cloud just lit up and started to glow, and we thought, oh my, did the spacecraft explode? And so everyone was holding their breath. A little bit later, it came up out of the top of the cloud and continued on its way to Saturn. Now, Cassini is a large spacecraft, and given the launch capability we had at that time, we didn't go directly from the Earth to Saturn. Instead, we had to borrow a little energy from the planets, and in particular, we launched here, had 2 flybys of Venus, a flyby of Earth, Jupiter, and on out to Saturn. So it took us 7 years to get to Saturn. And you can think of it as Cassini flew by, we slowed down those planets just a little tiny bit. And they provided energy like a giant slingshot to send us on our way at much higher speeds on out to Saturn. Then we were captured into orbit, and we have been in orbit for 7 years ever since. What's shown in the top panel here is here's the orbit of Saturn. It takes 30 years to circle the sun once. Cassini arrived just a little bit after the winter solstice in the north, 4-year prime mission, 2 years equinox where the sun is edged on to the rings in the planet's equator, and now we're 1 year into our solstice mission, ending in 2017, where the sun will be as high in the sky as it can be, so summer solstice at Saturn. And here are kind of some of the views from equinox out through solstice for the mission. The plot here just shows this is the declination